Discrete Transport System, ServiceNet Case Study. An example of ServiceNet could be a DTS-CNTT, Discrete Transport System with Central Node and Timetable, Wachowicz et al., 2007. This is a simplified case of the Polish Post Transport System. Following the definition, each elements of ServiceNet could be described as follows. The business service, BS, provided the Polish Post and therefore DTS-NTT ServiceNet is the delivery of mails. The technical infrastructure, TR, consists of a set of nodes placed in different geographical locations and set of vehicles and timetable. There are bidirectional routes between nodes marked by lines. There is distinguished one node called Central Node. Mails are distributed among nodes by vehicles. Each vehicle is described by following functional and reliability parameters: mean speed of a journey, capacity, number of containers which can be loaded, reliability function and time of vehicle maintenance. Management system, MS, is defined by timetable since vehicles distributing mails among system nodes operate according to the timetable exactly as city buses or intercity coaches. The timetable consists of a set of routes, sequence of nodes starting and ending in the central node, time of approaching each node in the route and the recommended size of a vehicle. The number of used vehicle, or the capacity of vehicles does not depend on temporary situation described by number of transportation tasks or by the task amount, for example. It means that it is possible to realize the journey by completely empty vehicle or the vehicle cannot load the available amount of commodity, the vehicle is too small. Timetable is a fixed element of the system in observable time horizon, but it is possible to use different timetables for different seasons or months of the year. To reduce the complexity of the model, we have decided to model the containers, not separate mails, Wachowicz and Mystery, 2009. Therefore, the tasks, J, of sending mails is modeled as a random process of containers generation. Each generated container has a destination address. The central node is the destination address for all containers generated in the ordinary nodes. Where containers addressed to in any ordinary nodes are generated in the central node. The generation of containers is described by Poisson process. In case of central node, there are separate processes for each ordinary node. Whereas, for ordinary nodes there is one process, since commodities are transported from ordinary nodes to the central node or in opposite direction. Postulated result of any task is to transport a container to the destination node within a given time limit. The process of any task realization could be described as follows. The container is generated in some node at a given time, according to Poisson process, and stored in the node waiting for the vehicle to be transported to the destination node. Each day a given timetable is realized. It means that at a time given by the timetable a vehicle, selected randomly from vehicles available in the central node, starts from central node and is loaded with containers addressed to each ordinary nodes included in a given route. The loading is done in a service point. This is done in a proportional way. Since the number of service points is limited, parameter of the central node, and loading takes some time as there is no free service point, vehicles has to wait in a queue. After loading, the vehicle goes to a given ordinary node. It takes some time according to vehicle speed, random process and road length. After approaching the ordinary node, the vehicle is waiting in an input queue if there is any other vehicle being loaded/unloaded at the same time. The containers addressed to given node are unloaded and empty space in the vehicle is filled by containers addressed to a central node. The operation is repeated in each node on the route, and finally the vehicle is approaching the central node when is fully unloaded and after it is available for the next route. The process of vehicle operation could be stopped at any moment due to a failure, described by a random process. After the failure, the vehicle waits for a maintenance crew. If it is not available due to repairing other vehicles, is being repaired, random time, and after it continues its journey. Wachowicz and Mystery, 2009. As suggested in the introduction, the simulator tool for analyzing DTS-CNTT ServiceNet was developed. The tool was adopting the event simulation approach, which is based on an idea of event, which could be described by time of event occurring, type of event. In case of DTS-CNTT, it could be a vehicle failure, and element or set of elements of the system on which event has its influence. The simulation is done by analyzing a queue of event, sorted by time of event occurring, while updating the states of system elements according to rules related to a proper type of an event. Wachowiak et al., 2007. We proposed for the case study analysis an exemplar DTSCNTT based on Polish Post Regional Center in Wrocław. We have modeled a system consisting of one central node, Wrocław Regional Center, and 22 other nodes, cities where there are local post distribution points in Dolny Śląsk province. The length of roads were set according to real road distances between cities used in the analyzed case study. The intensity of generation of containers for all destinations were set to 4,16 per hour in each direction, giving an average 4,400 containers to be transported each day. The vehicle speed was modeled by Gaussian distribution with 50 km per hour of mean value and 5 km per hour of standard deviation. The average loading time was equal to 5 minutes. There were two types of vehicles, with capacity of 10 and 15 containers. The MTTF of each vehicle was set to 2000. The average repair time was set to 5 hours, Gaussian distribution. Wachowiak and Mazurkiewicz, 2009. The simulation time was set to 100 days and each simulation was repeated 10.000 times. We have calculated the dependability measure defined by 10, the probability that the duration time of a task, delivery of some container, will be longer than a given time limit using Monte Carlo approach, Fishman, 1996. The achieved results are presented in